So go to YouTube live, just give like and give comments. Daily you can give likes. Emily is better others.
lunch. Now we have to develop the socks. We have got powered up with lunch. Right? So another 2 hours or 2+ hours. We have to get up. We have to get up. Okay? Okay, shall we start? Yes, sir. This side I am not seeing this. Yes, sir. Maybe this side more lunch, less lunch. Or less lunch, more lunch. Okay, good. Okay, now we will discuss one paper actually. One paper on solar power actually. So the paper titled Overview of Space-Based Solar Power. Okay. So by your Venugopal. Okay. So the paper deals with solar based space based solar power station, and of course it talks about efficiencies. 50%, 50 to 60% of solar energy is wasted as it travels through the atmosphere due to the high cost of transporting material into orbit. Space-based solar power devices convert sunlight into microwaves. So while doing this process, there are some inherent losses. So 50 to 60% losses will be there while transporting the power from space orbit to terrestrial. Terrestrial means earth only, on earth. What is terrestrial power? On earth. Terrestrial solar power means? No, on earth. On earth. So from morning onwards, we are discussing space-based solar power generation, terrestrial-based solar power generation. Terrestrial-based means which is your home. Solar panel which is located on your home, which is located on your college rooftop. Okay, this is our terrestrial solar power plant. Terrestrial solar power plant. Whereas ISS or SPS, space-based power station. You please kindly understand the difference. Terrestrial means we are talking last half day. Okay, it is nothing new. It isn't new. Okay. Now, so here, so the authors discuss the design of 3 elements. Okay, the 3 elements. Which are the 3 elements? The key elements which are required for accomplishing this mission, space-based solar power is microwave or laser beams, which are used to transmit the power from space to earth wirelessly. In this again, like the authors discusses pros and cons of laser as a medium and microwave as a medium. And what are the advantages if you go for laser beam? What are the advantages if you go for microwave? Okay, so clearly talks about if you use laser beam WPT, wireless power transmission, which has the receiver in the WPT of a laser beam, a system of optics mounts the laser light according to the needed beam size. That means the optics, design of optics will be taken care by knowing the design of beam size. It is not like that your beam size is bigger but your optics is smaller.
It can be.
So there is a mismatch. So there is a mismatch, or I can say under design. Your optics is under design, but actually it should be over designed, or it should match with the actual requirement. Okay, the DC power captured in space is employed to form a monochromatic light beam, a single light beam. So whatever DC power that is captured at space, that is used as a single light, monochromatic light beam. So the laser is targeted towards the designated earth receiving location. There is a retina, wherever retina is there. So this will be done by a control system. So the laser is targeted towards the designated retina through control system. Again, so control system means again you have to tune accurately. So to have a line of sight, to have the line of LOS, or in this case to match with the complete reception. Whatever power that is transmitting from the space, so we should have a complete 100% reception, power reception. So to this we have to tune our control system, okay, control system of the system to match both of this one, okay, right. Yeah, here control system in the sense the angle of your SPS, or the position of your antenna, concerns electronics, concerns sensors, or everything. So it comes to itself. Okay, pros and cons of laser beaming, laser power beaming. So what are the advantages? The main advantage is the interface with any of the communication signals will not be there if you use laser beam. It is a direct link, laser beam. The quantity of instrumentation required will be very, very less when compared to microwave transmission. So laser medium needs less amount of electronics, but safety safety point of view is more dangerous. So laser wave transmission, laser medium of transmission, if you are not taking care of the safety aspects as per safety class, which are standardized, which are accepted internationally, there are internationally accepted levels of safety when you are using laser pulse transmission, laser pulse reception. There are crude standards, so we have to follow as per the standards. Internationally accepted standards we have to follow. If you are not following standards, if you are doing the design, then it's a problem for the people who are working with the missions, with the hardware. Understood that? Yeah. Drawbacks or disadvantages or minus of this laser power beaming, or like this will get affected by climatic conditions. Laser, yeah, of course, like rain. So what will happen if rain comes? Laser will transmit through raindrop to scatter. So you don't get single beam from source to destination. It gets scattered. When once it's scattered, what is the power output? You don't get complete power output. So some losses will be there. So if you want to get 100 watt output, you may not get 100 watt output. You may get 100 watt minus X watt. Understood? So the X watt depends upon the losses. So what is the pattern it scatters? What's the intensity it changes after scattering? All those things will be coming. So it's one of the drawbacks actually. Hence, unable to deliver continuous electricity using laser beam, continuously 100 watts per month, no, it won't come. It won't come because of losses. You may get a lesser power. Okay. It has a limited conversion efficiency. efficiency and requires massive battery storage systems. If not properly treated, it poses a risk of skin and eye injury and more than that. Okay. Sometimes people who works on lasers, if you keenly observe their eyes, okay, they will be different. They will be different. They will be more bluish than normal person, and some problem with vision also. There will be some problem with vision. Provided sometimes they will be operating laser systems without taking care of safeguards, without using goggles, without maintaining minimum distance. See, if you are transmitting a laser pulse to 1 kilometer, for example, you are keeping it at only 1 kilometer, or you are keeping it at 100 meters, or you are keeping it at 30 meters. Okay, that time the reflected energy will be different in each of this case. So once you are very close to the reflected energy, first thing your eyes will be affected, and the second thing your skin will be affected. So it's very risky. You have to take safeguards. Like goggles you have to use. You have to be, sometimes what some primitive techniques what we will do, like generally on ground what we will do, if you are firing any laser pulse, I will turn 180 degrees by keeping my face towards back side. Now the reflected laser pulse, it won't goes to my eyes. It may touch my head or somewhere neck, but your eyes will be protected, safe. Okay? Some raw technique, some crude technique. Okay. So rectangle we are discussing what is the rectifying antenna. I'll discuss what is rectifying antenna, why it's called rectifying antenna, what is there to do this rectification action in the rectangle. We will discuss. Rectangle we are discussing rectangle from morning onwards. So rectangle, the purpose of rectangle is to receive the power transmission from the space. Okay, it should be more wider. It should be more larger, more wider. It should be able to capture, able to receive 100% of the fullest power, whatever coming from the space. The laser micro, see some approach, design approach will be having both modes, laser mode as well as microwave mode. So whenever you want laser mode, you can switch to laser mode. Whenever you want microwave medium of mode, you can switch mode to microwave medium of mode. Normally when we use laser mode, when there is no rain, there is no clouds, there is a clear sky, then we will go for a laser mode. If any rain is there, clouds are there, if any gassy atmosphere is there, dusty, so then we go for a microwave. So that the switching also will be, you can provide the switching in the design. So this approach is called hybrid mode of approach. If you want laser, go for laser. If you want microwave, go for microwave, depending upon the current situation. Energy receiving distribution, we discussed. Earth-based receiver, we discussed. Solar cell arrays. See, if you take terrestrial solar array means the solar plant which is implanted on the roof of your this one. Any doubts, please ask.
Ground surface. Satellite sends that wave. You can see that middle parts. For example, we are pointing laser on the screen.
There is some exhibition somewhere. Giving a plant. Need some light. Not that. That you want to go?
No, sir. No.
So that's also one of this one. Laser focusing on that.
We can see that middle part that we are not able to see.
With the naked eye. We want to see.
No, sir. I'm asking normally when the microwave or laser is transmitted from space to ground, sir.
Okay.
In that center, in that middle, we can see with the naked the path that we are not able to see. Now we are pointing on laser on the projector. That middle, the path of the
with lake rays can we see or not? But advisable not to directly not to see. So that's why the retina, wherever you are positioning the retina, it will be little far away from the retina. But still you want to see that that rays. That's what it is. So with special equipments you can see. With the special equipments, with the special safeguards, you can see. To completely 100% avoid any reflections, any bias mistake, so it's not only wise. But still you have to see it. Okay, good question. Okay, solar cell arrays, yeah, of course. Energy distribution discussed, electric receiver discussed, battery backup system, yeah. Coming to battery backup system is one of the important area electrical engineering section. Electrical engineering department, battery backup system is one of the area. So what are the types of batteries? Conventionally we use lithium-ion batteries, lead-acid batteries. Okay, so depending upon your requirement. And what is paper capacitor? Your paper capacitor. Very thin capacitors. So where you can store the energy, like value wise, weight wise, area wise, you will save the this one. Less value, less weight, more efficiency. Super capacitors. Have you heard this one? Super capacitors. So the advancements, developments to be they happen storage elements, which is the basic element of the storage capacitor. So conventional capacitors are batteries, I would say, batteries. So batteries, of course, storage elements also. Okay, so that's what your terrestrial storage system, space-based storage system. I mean batteries and backup batteries and the type of capacitors. Okay. Yeah. How do you calculate it? This is my capacitor bank. Capacitor bank. For example, you are generating some 1 kilowatt power. Okay, you are generating from 1 kilowatt power. How do you finalize? This is my capacitor bank. You got my question? You have got the 1000 watts output. Okay. In case the power reflections may be there from the load side. So or in case some fluctuations will be there. Okay, that time your system should have sufficient capacitor bank. Sufficient capacitor bank to produce higher power requirements whenever peak loads are connected. Okay, and to receive any backward things are there. You understand? So these two things will be involved in designing your capacitor bank. That means each of your capacitor, what is the capacity and what is the power, maximum peak power expected. So maximum peak power expected, up to that maximum amount you have to choose your capacitors which are connected in series parallel combination. That is called as capacitor bank. So there you can use conventional electrolyte capacitors or advanced super capacitors. Okay, for this one for storing power. You got the point? Capacitor bank, backup batteries. What is the type of battery in your mobile? What is the type of battery in your mobile? Okay, lithium. Why only lithium? So power conversion hardware, DC to AC, AC to DC again. See, there are certain elements from microwave theory, cyclotron, klystron. Have you heard last 2 days this terminologies? Cyclotron, klystron. So these devices will be used to convert energy into transmittable form. Got it? Yeah, coming to microwave medium, so again we see pros and cons. Yeah, advantages and disadvantages. Unlike the terrestrial solar, wind power plants, the solar collector in space is unaffected by daylight. We are talking from morning. So the collectors at the space, they are not affected from rain, all these ones. But on terrestrial, on the earth, it may get affected. Day and night. So cost aspects already we discussed. Yeah. Expected outcomes for reducing the cost. So the output expected if you reduce the cost from space, from lunar minerals launched into orbit. As a result of comet's impact, solar cells are being used. In addition, India is constructing a space station. Several rockets will launch to convey cargo. Okay, so here this point is like connected to your cost aspect and materials. What are the types of materials you have to use while manufacturing, while producing your hardware, while producing your subsystems. Subsystems for solar panels on Earth, subsystems of solar panels on space, and how to produce production aspects also. Production aspects in the sense how will be your production line. So how accurate your systems. For example, thickness of PV cell. So some thickness, how accurately it has to maintain production. So 100 units are coming as an outcome of production agency. All 100 units are meeting the requirements or not. The same thing for space-based also. So space-based solar panels, PV cells should be more accurately produced as per specifications, as per input given specifications. You understood that? So this is the PV cell which I am designing. It has to receive these many volts, means it has to receive. It has to produce. These the levels of range of the output levels, means it has to produce. Understood that? So no deviation in the design part. No deviation in the design part. Even a terrestrial also, spacecraft also. Of course, if it is a terrestrial solar panel, we can connect at any time. Tomorrow or day after tomorrow, whenever you go for a maintenance task, after a periodic maintenance, preventive maintenance, whatever maintenance you are doing, so during that time, you have a opportunity to inspect them once again. You have a chance to rectify them. But whereas these maintenance aspects in space, that's very tedious, time taking and cost involved also. It's not that easy as compared to terrestrial side. So that means the design aspects and production aspects of space-based PV cells must be very carefully done. Categorically, we have to inspect at each and every stage. Okay, subsystem wise, including each panel wise, each particular cell, each cell wise, you have to be very stringent. While design, it should be very stringent and it should be on par with the design. No compromise in the design. If you compromise, what will happen? So whatever design output you are expected, you may not get. You will get less power output. So the aim of the mission not met. Because many renewable energy sources are restricted, rising global energy demand is expected to continue for decades. Yes, the first page shows today morning. Solar power is the only best alternative energy source, since it has several substantial environmental benefits when compared to other ways of meeting the requirements. Very clearly, all these things. Morning we discussed why we have to go for a space-based solar power. Morning we discussed. No winter, no rainy season, no cold season. Always it's a 24/365 days. It's a sunny. That means the light intensity also very high for the solar rays in the space compared to the terrestrial area. Okay. So this is what we are in paper discussed. So the authors, very nicely figured out, categorically discussed about the pros and cons of laser and microwave, and they also discussed the production aspects also, even efficiencies. Now my thanks to the authors. All record. Okay, so coming back to our presentation. We are here, morning. Completed. Okay. We are here. This also completed. This one. Yeah. See here, you can see the design approaches. So this is the one design approach. See here, the resulting mirrors are placed like this. I mean, with some distance, with some gap of distance. Okay. Whereas in the previous approach, how the this you see this one. How it is placed, like the solar concentrators, like it is like parabolic. This one, like curving, the curving. This one kind of design approach. Okay, so these are different ways of designing your SPS, space-based solar station. Okay, yeah. Now one person asking, good question. So can we see directly whatever laser beam transmitted from space to Earth or microwave, whatever power transmission from? So here you can see the right side part of the slide. So from the you can see the beams how it is coming and how those are received by the retina on the Earth. Okay, it's a completely protected area. The retina side for completely protected restricted area and no human involvement in between. I mean, while the energy is being received and then energy is being stored by the storing elements there. So safety aspects, safety point of view. Okay. I think you have covered this. Yeah, this also been covered last aspects. Basic ideas. Okay. Now commercial, station, commercial space is also completed. Yeah, now what are the 6 challenges? The major 6 challenges while designing the SPS, space power station. So just I'll repeat once again: wireless power transmission, WPT, space transportation, construction of large structures in orbit, satellite altitude control and orbit control, power generation, power management. Out of this all 6 challenges, like one of the daunting area, one of the gray area is WPT, wireless power transfer, and how to address the issues by transferring the power from space to Earth without losses. How to do the power transmission wirelessly with minimal losses. What kind of design care we have to take both at the transmission side, even at the receiving side on the Earth. Okay, and after receiving, again how to store that received energy, and after storage, and how to store the power, how the power transmission can be done for the loads, individual loads, using in between or interim power grids, or some mediums through some means, so the received energy will be supplied for the demands from the individual loads. Here comes your power management system on the Earth. So once the power is received, once you store the power, so there are n number of nodes connected wirelessly or using wire, whatever it is. So depending upon the requirement of each node, what is the nominal power requirement for each node, what is the peak power requirement for each node, based on these requirements you have to design power management system by capturing all the nodes, all the loads into the software. So depending upon the requirement, depending upon the selection of the user, you want to supply, you want to cater power, nominally operating or peak power operating, all these things the user has to provide for the loads. Yeah, I think we are here. This is one kind of design approach you see. So the two disjointed mirrors are placed. Again mirrors in between, solar panels are there. From solar panels, as we discussed earlier, so again electronics are there, microwave conversion, energy, microwave, like laser development, warning pieces. If you are using laser as a beam as a medium, concerned electrons will be there. If you use microwave as a medium, concerned cyclotron, like a klystron, all those microwave elements will be there. Yeah. Now, what are the different processes involved in designing a basic PV cell? What is the PV cell basically, and how it is designed, and what are the different very basic science processes are there. See, generally PV cell, like a photovoltaic cell, as we were discussing this before lunch also, solar energy conversion, like solar photons to DC current will be here. So the solar electric systems convert the energy obtained from the sunlight to DC first, direct current, or the type of electricity that used generally in our day-to-day batteries, in which the flow of electrons is in one direction, the same direction where current is flowing. So the solar cells, which generally consists of two layers of silicon, along with a separation layer. So these two layers are connected using a wire, top layer and a bottom layer. So the whatever electrons which are there in the top layer, so this will interact with the protons of the whatever sun rays are received by the PV cell. So that photons from this one will be interacting with the electrons, and that will spread actually. So it will interact again, it will spread. Complete top layer electrons whatever present, they will interact with the fullest to the photons. Then, so after that, after completion of that one, slowly they will spread it to the bottom layer also. So whatever electrons in the bottom layer, so they also will try to attract to the photons, so that the current will be flowing from top layer to bottom layer. So this how the current will be constituted. Current will be formed in basic PV cell. If you read about the design of the basic operating principle of basic photovoltaic cell, and this is the thing which is happening actually. So the photons from the sunlight obtained from the sun, it will interact with electrons in the upper layers, upper silicon layer, knocking them loose from their associated atoms, which are then attracted to atoms in the lower layer of silicon and travel through the wire to get there, which causes the flow of electric current. Basic operation of the operating principle of the PV cell, photovoltaic cell. Yeah, how can you make a PV cell? So the photovoltaic is nicely descriptive. So the PV cell are wired together in series during the production, so that the output voltage of the panel depends upon the number of cells in the cells. For example, you need some 10 volts. So you have some 2 volts output PV cells are there. How will you connect them? So you need 10 volts output. You have some 2 volts cells are there, 5 are there. So whichever combination you want, series combination, parallel combination, whichever, or I want some 5 volts only. I have 1 volt PV cells, 10 are there. How can I connect? Okay. So like that series parallel combination, you have to work out. You have to connect such a way that you are getting desired output. So that's what your solar array. We will say the solar array. So solar array comprises of series and parallel combination of the PV cells. Yeah. The output voltage is dependent on the efficiency of the cells and the size of area of each cell in the panel. So if you want some 10 volts output if you want, the panel, the solar panel monitoring resistance should be over designed. Okay? You should design for 12 volts. You should design for 11 volts. So then only you will get the 10 volts output. If you design for 8 volts, for example, what is your output voltage? It may be 7, it may be 6. Addressing losses. So that's the point here. So the output voltage, the output will be depending upon the size of efficiency of the cell, size of the cell, area of this one output. Panels made using more efficient cells, this will tend to be more expensive, of course. So more highly efficient means more design. Highly efficiency is very high means it's over design. So cost overrun. Over design is cost overrun. You look to use more hardware or more critically, like high standard hardware you want to use. Okay, so that is cost will be more. So these are the issues. However, they are not perfect in practice. As these materials, like the purity of the materials affect performance, though it has been improving progressively from some 20-30 years. Yet some of the new thin film approaches are less efficient, about 20%, 35%, the best class of each. That means, so here we are talking about the efficiency of the PV cell. What is the material you are using for the silicon layer formation? So I told 2 layers of silicon, top layer and the bottom layer. So what is the purity of the silicon you are using? So how good you are using, so that correspondingly we get the output voltage. That means if the input is X, output is X, 100% efficiency. If the input is X, output is X minus delta X. Efficiency is not 100%. 100 minus delta X, right? So to address the 100% efficiency or fullest efficiency, your design should be that you have to use the good subsystems, good components, which are expensive. So the currently this thin film approaches, so for the PV cell, so this is also about the efficiency, like 20% or 30% efficiency. Remember my statements from morning. I asked yes or no, no or yes. Modes of transmission of power, wireless, WP, wireless power transmission. Okay. So here, all these aspects comes into your design approach. So before designing your hardware, you have to study what are all the different ways available. You have to choose the best way for the design actually. Okay. So the technology for wireless transmission is in the forefront of electronic development. Of course, nowadays we are going for Wi-Fi, Sci-Fi, okay, Bluetooth, everywhere Wi-Fi is taking the highest priority. So now we are talking about wireless for space-based power, the highest, the peak, the pinnacle of mountain, I can say. Okay. Yeah, here I want to discuss this one. We are doing DRDO. So DRDO also entering in this. We also entered in this area of solar power generation, and we have projects running at Siachi, Himachal Pradesh, Ladakh, Leh, Kashmir, mountain areas. So there we are facing the problem of battery storage, capacity banks for storage, even for maintaining the temperature in the army tents, So in the winter season, it's very difficult to sustain minus temperatures, -10, -20, -30, all that. So to keep warm tents, army tents, so there we use a high altitude. So we use the solar power generation. So we generate during the daytime. That power we will use it during night time for warming of the army tents. And one more is a very big solar plant, more than 10,000 capacity at Kolar, Karnataka, Kolar. So near Kolar, the DRDO we are very huge power plant, very big. So one of the largest in the So we are also working on solar power, especially mainly at the high altitudes, Leh, Ladakh, Siachen, and at the polar altitudes. This whatever power we are getting from solar, that is used for different purposes. So for powering of the stations, mobile stations, and for similar defense applications. Okay, applications of WPT like involving microwaves, solar cells, lasers, and the resonance of electromagnetic waves have the most recent success with the WPT, whose main function is to allow electrical devices to be charged continuously and use the constraint of power cord. Okay, the thing here is there are two modes on terrestrial axis: near field and far field. So near field means where is your antenna and where is your both electric and magnetic fields are interacting. So whenever electric and magnetic fields are interacting around the antenna, how close the current is flowing to the antenna with respect to the antenna. So that we will call it as a near field actually. So here, so the short range or near field this one. Here, so how to design the range means the range, whatever the range is less than or equal to the diameter of your antenna. So diameter of your the range is less than or equal to the diameter of the antenna. Whereas the mid range is so when you are away from the antenna, main antenna, so there you can use the inductors. Inductive mode of power this one transmission, which we will call it as a mid range or this one far field. So by designing, so the range less than equal to 10 times of diameter of your this one antenna. So this is the near field, the non-radiative region. So which means that one wavelength, one lambda you can take. So one lambda is the reference of the antenna. So how close that field, electromagnetic field with antenna. So near field and far field. Near field, I think two ranges I put, short range and mid range. Far field, we will discuss in the next slide. So here you can see the bottom right corner. So there are two power sources. So the oscillators are connected after the power source, and the inductors L1 and L2 are connected. So that the electromagnetic inductive field will be generated, magnetic field. Then rectifier is a rectifier. So after rectifier, power is connected to the load. So whatever the load that is driven down from the rectifier. Same thing in the bottom, if you see, that is purely this one inductive, this one wireless inductive, this one resonant LC combination in the bottom. This LC combination and the top side only purely inductive nature actually. Yeah. So there are two different techniques we can say, near field and far field. So in a near field, we can say four different configurations you can approach for designing your this one. Inductive coupling, I mean how your coupling with respect to the antenna, capacitive coupling, resonant inductive coupling, resonant capacitive coupling, and magnetodynamic coupling. This is with respect to near field. Okay. In far field, microwaves and the power transmission via radio waves that will be considered in the far field. So the efficiency is very good for the microwaves, almost 95%. Copying the presentation into pen drive, an exam point of view. There for 2 minutes, I'll copy this file. Okay, welcome back. Short gap. Okay. So practically, like what we are seeing, what we are experiencing as of now, microwave-based experiments, like which led to very good results. So these powers is sufficient to meet the requirements of helicopters, balloon-based platforms, experimental airplanes, of course, like rovers. That means through this microwave medium, whatever power transmitted from space also. So that is sufficient. I mean that is meeting the requirements of like helicopters, balloon-based platforms. What are balloon platforms? What are balloon-based platforms? Parachutes. Okay, good. Any other? Yeah. Like balloon means maybe you can think of the size of like 2 of these rooms. Okay, so this room, this hall is there. You assume another hall is there, the same size. Okay, this much size balloon. Okay, so this much size of balloon. These are generally used for aerial deliveries. Aerial deliveries. You are putting some load, and that load need to be delivered at some other place. It has to fly, it has to travel, it has to fly down, it has to deliver. So that's the purpose. So balloon-based platforms. So this also needs power, right? This also needs power for pick up the loads, for traveling, and then for dropping the loads. So aerial delivery, aerial delivery, air delivery. Helicopters, you know. Experimental like aeroplanes, okay. Experimental cars and rovers and cell phones. So yeah, once helicopter requirement has been met means obviously your mobile requirements will be met. Maybe 100 people from the student community you will get power sufficient and more than that also, more than that. Okay. Whatever high power mobile you are using. You may be using mobile with all facilities so that more power is required to operate that mobile with all everything. Just put like this, it will come. Okay, there will be mobile. Actually, there is no mobile. Okay, so for that also power is required. No, hey, it is there. I mean the technology is there. Okay, so just do like this. So you will see the screen. Yes. Okay. Now you can see your heartbeat. How many steps you are moving. Everything on your hands, palm. Okay. So the first experiment was conducted by one scientist called Rovi in 1964. The first rectangle has been used and it was invented and used in 1964. Way back 1964. Yes. The longest distance between emitting and receiving points achieved so far, in the order of hundreds kilometers. So far, whatever achieved, whatever we are discussing as of now in reality, power required. I mean, helicopters, balloons, platforms, all this we are discussing now. The distance covered is hundreds. Kilometers, hundreds of kilometers. Okay, less than not more 1,000, 10,000, not like that. It's hundreds of kilometers. So the largest amount of energy transmitted so far was during an experiment done by US Jet Propulsion Laboratory in 1975 when 30 kilowatts were transmitted from 26 meter diameter parabolic dish. 1.54 kilometer distance antenna with 8,000 pins. What is the diameter of antenna used for Chandrayaan mission 2? What is the diameter of the antenna used for Chandrayaan mission 1, mission 2? It may be of this moon size, very big antenna, Chandrayaan moon mission. Parabolic antennas, very bigger size. So those kinds of more than those physical size and all required for our space-based requirement. So as of now, the tested was 26 meter diameter parabolic dish antenna. Okay, 26 meters means you can assume physically this room is having maybe some 10 meters width or some 40 meters width. Okay, so twice of this room. One hall and another hall. So that much diameter, 26 meters diameter antenna has been used. Yeah, the distance 1.52 kilometers, antenna with the efficiency 85%. see conversion of DC to microwave power. How? Okay. So the DC power is converted into microwave for transmission into Earth actually from space. So the DC power is converted into microwave for its transmission through the antenna and to its receiving antenna in the Earth as antenna by using microwave oscillators like electrons and magnetrons. So an AC current, the alternative current is created for transmission in the elements by applying the voltage at antenna terminals, causing the elements to radiate the electromagnetic field. Okay, so that means you have to convert the DC into AC field, like using your magnetron or electron. After that AC, once you generate AC, that will be given for the antenna. From the antenna, it will be transmitted into the outside transmitted. So whatever transmitted, so that will be received at the antenna. Okay. So here thing is DC to microwave power conversion. So there you have to use klystrons and magnetrons underline. Okay. So what are the devices used for a conversion of DC power to microwave energy? Klystrons and magnetrons. So this is for microwave conversion. Of course, lasers, if you discuss lasers, so the first attempts to transmit energy wirelessly with the purpose of doing so are attributed to the Tesla car, right?
Yes, sir.
Very advanced. You see the PMSM motors, permanent synchronous, permanent battery synchronous motors, PMSM motors used in the cars, Tesla cars, awesome design. So like on-car is very very Tesla, they are very good at motorcycles. Okay. So they have done the first time wirelessly this experiment at Long Island, New York, 30 years ago. After some Maxwell, he has predicted something 1973, and of course some history. Transfer of the energy, though an atmosphere, transparency of the atmosphere to a used wavelength and directional emission. Convert energy from the source to the transmittable form, and you discussed. Convert transmittable energy into drawbacks. What are the drawbacks? Laser radiation is hazardous. True or false? Laser radiation is hazardous. True or false? Why true? What is the wavelength of laser? So maybe ICF, non-ICF, two things will be there. So ICF laser to take around some very less, 1.5 micrometers, maybe very less than that. Non-ICF lasers, the wavelength will be different. Okay, will be different. And ICF lasers, as per safety class 2, the safety class, some levels are there. M2, M2 I think so, safety class. Non-ICF lasers, different standard is there. Okay. So while playing with lasers, you have to be very particular about standards, internationally accepted standards, safety classes. You should not violate those standards. Low power levels and low power levels of laser that can make you blind, and also animals. See, for example, sometimes that means you are the operating person, you know laser pulse to transmit, and you know the reflected is coming, reflected laser is coming back, and if any animals are there by chance nearby, whether will they know?
No.
Are you telling them? We are not taking care of them. So that is also required here. That means what is the point here? You have to play with laser only in the areas where you have to evacuate any animals are there, any other children are there, any elderly people are there. You have to evacuate them in safe environment only. You have to play with laser. You have to use laser. That is the point. High power levels can kill through localized spot hitting. Okay, so there is a possibility for killing also. So maybe each one can design laser weapon. Okay, conversion between electricity and light is limited. Using lasers. PV cell achieves 40 to 50% efficiency. Atmospheric absorption and scattering, absorption and scattering, requires direct line of sight with target. So like pros and cons we are discussing. With laser, what are the pros and cons? With microwaves, what are the pros and cons? Okay. So with laser, what are the advantage? Advantage is highest amount of energy
You can generate.
Efficiency is very high. So it's a very highly directional. Laser beam is highly directional. There are less losses. But what is the disadvantage? It is dangerous. It is dangerous both for humans and animals. Okay, pros and cons of laser beam. You have to see the picture, right hand side. There is a like PD array on this one, base from the space. So there is a like laser beaming of like space power. It has been received by the antenna at Earth. Okay, so 10-meter mirror is in the diameter of this was proven actually, which is reality. Now, so as of now, we have seen different stages of design. So the first stage is design of isometric mirrors, design of reflectors. Next, converting DC power into AC power using magnetrons, klystrons, all that. So this is at the spaces. Yeah. So there again selection between the laser medium or your microwave medium. So depending upon the requirement, you can also use hybrid topology. If you want laser, you can switch to laser. If you want microwave, you can switch on to microwave. Hybrid system also we discuss. Now you transmitted the power from space. You are at the end. You are at the receiving end. So on the receiving end, what are the requirements? What is the antenna required? What is the diode? You want to be Short diode? If you want to be Short diode, why only Short diode? What is the advantage of Short diode? Okay, in parallel to your antenna. Okay, and what is the type of antenna? Dipole antenna. Why only dipole antenna? Okay, how basic this one antenna can be designed. So how many dipole antennas should be connected? Okay, to meet the antenna of 1 kilometer, 2 kilometer, to meet this antenna. And so all these things will be discussed. This is the another phase of design. Okay, phase 1, phase 2, phase 3. Okay, now transmitting antenna. Yeah. The microwaves can be then converted back into its original form as DC or AC current by using a retina. That means whatever power received by the retina, again to use that, what you should do? You should convert back AC to again DC. Okay, so from DC again you have to charge the batteries. You have to use the loads for powering of the loads. Okay. Now here a retina, like rectifying antenna. It is a special type of antenna used in the process of converting electromagnetic energy, that is AC, into your direct current electricity. And these are used in wireless power WPT systems for transmission of power by radio waves. Okay. A dipole antenna with radio frequency diode connected across the dipole element constitutes the simple rectangle. One simple element rectangle, rectifying antenna consists of dipole along with one Schottky diode with filter. Filter any ripples are there, take care of the ripples to give the pure DC. Okay, and load is connected to the output of the antenna. Fine. The AC current include the antenna by microwaves rectified by the diode in order to produce DC power, which powers a load connected across the diode. Okay. Schottky diode usually we will use because they got the lowest voltage drops, that is highest efficiency. And cost wise also is less cost. Okay. Why it is less? Because due to losses are very less due to switching or due to conduction. Large rectangles consisting of the array of many such dipole elements as we already discussed. So large rectangle how we construct by connecting multiple numbers of dipole antennas. Okay. Now transmitting antenna. So even though the wireless transmission is deemed possible for short distance, like transmission of this power becomes more difficult. If they increase the distance of transmission, of course from space to earth, the distance is very much increased. So the point here is the area of the rectangle should be wider enough to receive the power which is transmitted from the space. So maybe 13 kilometers, whatever is in the reality taken from the Wikipedia as well. So here the antenna, the measurements of this antenna are 13 kilometers. north south, 10 kilometers east west, the rectangle. So 23 milliwatts per centimeter square maximum. That is 0.003 watts per meter square. Less than 1 milliwatt per centimeter square at like rectangular edge. On edge and edges, what is the efficiency? Edges means any energy that falling on the boundaries. Now we are coming into the design. Now we got it out. What we discussed as of now. Okay? Right now? Okay. So all the design will be. All the design. At least, okay, now you got some idea. So how it works, how to design, the basic idea, concept of space solar power. Okay? So now, other parts of design, maybe more in details. Like already discussed the topics, only will come. Anyway, we will see any new topics are there, we will discuss. Two methods conversion have been studied, like photovoltaic and solar dynamic. PV cell and solar dynamic. So here, we have to maintain the synergy between the space-based system and terrestrial-based system. That means the terrestrial solar panel, space-based solar panel, you have to maintain the synergy. What is the efficiency levels, and what is the medium you are using, and what is the components you are using, what are the specifications, what is the design approach, design methodology. Okay, so tomorrow it should be like compatible in the sense maybe the terrestrial platform can be upgraded to meet the space-based platform. You got the point? So you have to maintain the synergy input levels, output levels, amount of losses. So like all maintainability aspects also, production aspects also, so replaceability aspects. Okay, all these aspects you have to maintain the synergy. Okay, we have some two subjects. Both are tough. Okay, so there is no leave in between. You have to maintain the synergy, the preparation. Okay, so half day one subject, another half day another subject. Full day one subject, 1 hour another subject. If you like this, no synergy. In one thing you will success, another thing you will get failure. So you have to give equal importance, equal priority. Okay, in the same way, terrestrial-based solar panels, power panel system, and space-based this one, both are. You have to give the priority. You have to maintain the synergy. It's like to meet the aspects like maintainability, replaceability, all those things, upgradability, like terrestrial power plant or power panels, you can upgrade to directly put on the this one orbit. So like that you have to maintain upgrade in the sense LRU, you have to use LRUs, line replaceable units. So if this is not working, you just remove this one, plug and play. So those techniques you have to use by designing your systems. Plug and play technique we use in the design ways. Yeah, so there are two methods like the photovoltaic and solar dynamic. Photovoltaic conversion uses semiconductor cells to directly convert the photons into electrical power electrons. Solar dynamic uses mirrors. That's what I told. So horizontal mirrors you can use. Horizontal mirrors you can capture the solar rays that you can convert into your this one. So semiconductor device, that is photodiode, right? So semiconductors you can use or mirrors you can use to generate the energy. That is called SD, solar dynamic. Most analysis of the space-based solar panel have focused on PV, okay, commonly known as solar cell. Wireless power transmission was proposed early, called as a means of transferring energy from connection to the Earth's surface using either microwave or laser radiation or variety of means. Advantages like collection of solar power, there is no air in space, so collecting surfaces could receive much more intense sunlight. Space solar power can be exported to virtually any place in the world, and its energy can be converted for local needs. What is this point? Just by changing the orientation of your orbit, assignment satellite in the orbit, you can move your retina, or you can put some new retina in America, China, Pakistan, wherever you want, or in Japan. So you can export your space-based power. Very important, very valid point, right? So you have some two plants, new industries, solar industries in India. Tomorrow, if you want to develop two more industries in Western countries, okay, so there again, when you go there, you do design only ground-based rectangle. You need not to redesign the orbit station. So that's already fixed actually. So that the exportation of power to other countries is very, good, easier, virtual. So what we need to do? You need to do some separate rectangle to the place where you want to transfer, where you want to transfer whatever you say. Collecting surfaces could receive much more intense sunlight owing to the lack of obstructions such as atmospheric gases, clouds, dust, and other weather events. Consequently, the intensity is, already discussed. It's a very clean energy. Solar energy is very clean. There is no dusty environment, no cloudy, no rainy, all this one. Approximately 144% of maximum attainable intensity on Earth's surface. That means if 100 is on Earth, means 144 on this one, space. The satellite could be illuminated over 90% of the time. Okay. Orbiting satellites can be exposed to a consistently high degree of solar radiation, generally for 24 hours a day. Whereas average Earth surface solar panels currently collect power only 29% per day. That means only peak hours, maybe 12 o'clock to 2 o'clock. Or some 11 o'clock to 3 o'clock, 30% of a day. 24 hours a day means 30% of 24 hours. Only you are connected with the solar power on terrestrial platform. Whereas in space, this one 100%. You can use 24 hours. Power could be relatively quickly redirected directly to areas that need it most. The collecting satellites could possibly direct power of the demand to different surface locations based on geographical location or type of load or peak load power needs. Okay. So if you have requirement in Hyderabad, suddenly you got some new requirement at Delhi. This is very easy. Switching is very easy. Okay, only you have to be flexibly. You have to operate your power platform. Flexible operation of platform. Okay, is by changing your angle. By changing your angle of rotation, you can see power output at Delhi. Here the point to be highlighted is flexible operation of systems, terrestrial as well as space-based. Typical contracts would be for base load, continuous power, since peak power is now. What is US PRC Japan? USA PRC
People's Republic of
PRC People's Republic of China. Fine. So the people are aspiring to design and develop a space-based solar farm that would generate 1 gigawatt of power. This has been done as of now. What is done I am discussing. It is to transfer back to the Earth through microwaves or lasers. This will require an area of 4 square kilometers consisting of rows of solar panels. This space solar farm will be housed at 36,000 kilometers above the Earth's surface. Okay. So, for example, tomorrow, you have a requirement tomorrow as an engineer or as a CEO of a company, you got the problem statement saying like this. So you have to design and develop, you have to manufacture a space-based power station which gives 1 gigawatt of power, and you have the 4 square kilometer area you are having, and it has to house 36 kilometers above the Earth surface. This is a problem statement. Now to meet this statement, you have to start your design on paper. Okay, so on this 36 kilometers above the Earth, what are the things required? What is your launching vehicle required? And how much length of your launching vehicle? Then to do a plant there for 1 gigawatt. So for generating 1 gigawatt of power output, what is the power to be produced? It should be obviously more than 1 gigawatt. Okay, so if that is the power requirement, then how will be your gigantic mirrors, giant mirrors at design. Okay, what is the diameter of the design? So what is the reflectors? How many reflectors you have to use? 1, 2, 3, 4, 10 numbers. Then again, how to convert that power into DC to micro AC power. Again, whether you want to use laser mode or whether you want to use microwave mode, all that you have to decide, or hybrid mode. So that stage by stage you have to start your design. So here these pictures are important. 1 gigawatt, 4 square kilometer, 36,000 kilometer above the surface. Like this, one problem statement will be generated. Based on that, you have to do the design. So, like these space-based platforms are already, like US, DRC, Japan, they are like working very tightly and very seriously. Yeah. Like as of now, we have seen the laser as a medium. Laser as a medium. We have discussed about safety classes. We have discussed about laser diodes. We have discussed about highly directional, less losses, high efficiency laser and all. Pros and cons. If you go for a microwave medium, power transmission via radio waves can be made more directional, allowing longer distance power beaming with shorter wavelengths of electromagnetic radiation. Typically, in the microwave range, an antenna may be used to convert the microwave energy back into electricity. Yeah. NASA, some facts. NASA studied the solar power satellite required 1 km transmitting antenna, 10 km receiving antenna. Okay. Why receiving antenna of 4 km more diameter? It should be right. Yeah. For microwave beam at 2.45 gigahertz. Experiments like in the tens of kilowatts have been performed. Conversion efficiency was achieved at least like 54%. Like there is a conversion efficiency achieved in this mode of transmission. So that one design approach what we discussed. So there are like giant mirror like 2.5 kilometers. You can see 2.5 kilometers distance. Okay. So photovoltaic cells in between. So that this PV cells will convert this light energy directly into DC electricity. Okay. So on the left hand side you can see concentrating mirrors that to collect the solar rays. So concentrating mirrors will collect the solar rays and that will be falling on this one reflectors. Then that will convert solar energy into DC electricity. Again, microwave transmitter dish, the center bottom white color you can see circular element. So that is like a transmitter dish. So from there, again, it will power is converted from DC to microwave form using your like magneton or electron. So that will be transmitted to the rectangle which is placed on the ground. So high energy microwave beam is transmitted from space to earth. Ground based receiver like which we call rectangle, which will captures the energy coming from the microwave beam and converts it to the electricity to store in the batteries and which supplied for the loads purpose. Okay. Laser power beaming. Again, we discussed all this. Power can be transmitted by continuously to laser beam that is then pointed at photovoltaic cell. Compared to other wireless methods, it is like collimated monochromatic wavefront propagation allows narrow beam cross section, narrow beam detection, compact size compared to microwave, no radio frequency interface, and access control. Only receivers picked by the laser receive power. Yeah, laser. So here again, primary mirror, secondary mirror, solar mirrors in between. Then instead of using magnetrons, klystrons, here you are using laser diodes. So laser beam is transmitted from space to ground. So that you can see the distance here, 5 kilometers from primary mirror to secondary mirror. The previous it was 2.5 kilometers. Yeah. Earth-based receiver. Earth-based receiver would likely consist of many short dipole antennas connected via diodes, Schottky diodes, what I mentioned. Microwave broadcast from the satellite, that means the space station, would be received in the dipoles with about 85% efficiency. Rectangles would likely be several kilometers across. The diameter of the rectangles would be much more wider than the transmitting. Yes, one of the retina photo we capture. You can compare the tower adjacent left and right. Those towers for transmission. power, whatever power coming from the rectangle. So that power is you can see the batteries three sides. So that will be stored in this batteries. So from this batteries, after this one, we go to the towers. So from there, power will be transmitted to the towers. It will be given to the loads. Wherever loads are there, power will be given. Yeah. Of course, we have seen some summary. Okay, now, can you name three major advantages of space-based solar? Three major advantages. Okay, one. Renewable. So I will accept all answers. 24/7. Good. Excellent. Next.
No day.
No? No day. Okay, accepted. No day and night. Accepted. No peripheral disturbances. Okay. Unlimited energy. Excellent point. Yes. There is no limitation at all. You can keep on generating power. Sun will keep on giving energy. No? No rain. No clouds. No scattering. No rain particles. No electricity bills. Very valid point. Very valid point. No electricity bills. Yeah. We can have our own solar panel on our rooftop, and we can design our own PV cell. And if you want to put some extra fan, I'll add one more PV cell. If you want to have some LED TV, some bigger screen, home theater, add two more PV cells. No, that's all. Yeah, wireless. Remote power supply. Yes, good point. There is no electricity bill in India. Very valid point. Since solar that's free of cost. So why no bill? Since energy from sun is free of cost. Okay, I don't say low maintenance. Low maintenance. Yeah. Sorry, low maintenance. Yeah, you are right. Low maintenance. Integration. Light output. Okay. High energy output. Yeah, good. Right. Second, advantages of space-based solar. Come again. Excellent point. Very valid point. So carbon emissions, the greenhouse effect. Okay, that would be like good. Very good. Different angles. Okay. So export also easy, right? Export. Exporting to other countries. I told you, right? It's very easy. Any passport required? No, right? So from space it's coming. That's all. There is no license or there is no any IP address required. Correct? But of course, they have your control. They have your control. So if I know your retina design, without knowing you, I can do one more retina in some other place. I orient like a space station to match my retina. Provided that you should know your design. You should know your angle theta. Okay. Okay. Now, so these are the advantages. Now, what are the major challenges? Major challenges in the space-based design. What is cost aspects? Okay. Next. High maintenance efforts required. High maintenance efforts. Okay. Okay. Yes. Need technology upgrade. Yes, yes. So technology to be upgraded to meet the power requirements. 1 gigawatt power output, 2 gigawatt power output, 10 gigawatt of power output. So you need the technology. Yes, you are right. Distance.
Risk factor.
Okay, okay, yes, valid answer. Any other challenges? Many are there challenges. Satellite maintenance. Yes, yes. Lifespan. Okay. Actually, once you design and put it to orbit, like maintenance, it may not that much required. Once you place it in orbit, compared to this one space, terrestrial based, you don't need that much. But of course, periodic maintenance, 10 years once or 20 years once, you have to see the efficiency operationality of the challenges. But you have to, you are not discussing the medium. Medium for this one, laser. Laser, if you are using laser, these are the problems. If you are using microwave, you don't get fullest output. I mean, but efficiency will be limited. Okay, so that is also one of the challenges. I mean, you have to design your laser devices considering safety into aspect. That is safety into aspect. Any other challenge? Storage. Storage wise, you need devices to store. See, you told 24/7 power can be generated. Where you put that? You generated power. You should have battery. That's what battery. Backup battery. What is the capacity of backup battery? Whether it should be able to store 24/7. What is the size of your batteries? You understood my question? That is also one of the challenges. Okay. So you should have sufficient backup batteries. You should have sufficient storage mechanism. Storage mechanism. That is also one of the capacitors. You have to design your capacitors, low cost, less value capacitors, economically. Any other challenge? Yes, very good point, very valid point. Supply chain, management, supply chain management. Today, I purchased my 1 kilometer diameter giant mirror from one of the company with my design, manufacturing company. After 10 years, he got losses. He closed that company. Now, who will give my mirrors? I don't have any alternate source. I don't have any alternate vendor. What should I do? I have to start from scratch. I have to develop another vendor. I have to give the specifications to him. I have to explain him the transfer of technology. I should tell him the processes involved in manufacturing. So this is a time-taking, tedious, cost involvement. All things are there. Supply chain management is one of the challenging tasks, the challenging aspects. Radiations. Yes, very valid. Safety of humans, safety of other animals, birds, other life being, whatever is there. So that we have to ensure. Okay, so now, yes. Yes, that means transporting people to orbit is a tedious job. Okay, nobody will agree. Yeah, good. Break fire.
4 o'clock.
ప్యాకెట్ పెట్టావా
welcome back to the last session. Just check your syllabus paper. If it is topics to be covered, whatever mentioned in your table, today's concepts. Just take my just I will read out the information of what earth and space-based power concentration, power generation systems, solar collectors covered. Solar collectors we discussed in the morning, right? Next, space solar power covered. Yes, okay. Terrestrial solar power means on the earth, on your house. Yes. Terrestrial solar power cover, yeah. 3 elements of space-based solar power covered.
Yes, sir.
What are 3 elements? Same only, like the mirrors, and then the magneton, clystrons, then your medium, then your rectangle. So those are the 3 elements. Okay. Coming to article discussion, space-based solar laser systems. Like simulation to transfer power. The paper discussed, no? I think you discussed paper. If you want to discuss once again, it will not require. Why do we are talking that only? Next, after lunch, space and terrestrial synergies from the terrestrial perspective. Okay, space and terrestrial synergy. That was this what I told. That means your solar system on space and solar system on earth, both should be like maintain synergy. So tomorrow if you want to upgrade, one means you should be upgrade. You should have to be upgrade. Say for example, you got your mobile with 2 ports, mini USB and micro USB. Is it good or not? Say tomorrow your Oppo company coming up with one option. All your B type ports will be C type ports will be whatever is there, old one. B type ports will be compatible with the C type. This is upgradation. That means they have to maintain this synergy, upgradation. That's good, no? See, I have one mobile with old port. Now new upgrade is coming free of cost. So good only, upgrade only. So like that, you have to maintain the synergy of the versions. Version 1, version 2, version 3 systems. Okay, that means this year you are producing one system with one configuration, means that same configuration you have to maintain further also. Then only upgradability will be easy. You understood that? Otherwise, this year you are making one system. Next year you are making another system with another configuration. Then how do you maintain synergy? Yeah, now the point discussion is the synergy, maintaining synergy among the systems. For example, today you are developing system with one configuration. Okay, two giant mirrors, for example. Next year you will develop one system with the same single parabolic mirror. So if you do different designs, one here, one, how do you maintain upgradability? How do you maintain synergy? Difficult, no? So tomorrow cost also will become high. So here what is the point here? You have to maintain the synergy. That means upgradability you have to maintain. So the system which you done and pay, tomorrow you are supposed to upgrade. You should have a provision. In the design for future upgrades, for implementing future upgrades. So that is the point actually. Next. Okay, if you are not maintaining this, what are the problems? If you are not maintaining this synergy, what are the expected problems? Yes. If you are not maintaining synergy, what are the problems in your case? For example, you are training, you trained 2 technicians in one configuration of the design using a giant mirrors, 2 numbers, that design approach, you train a few manpower. Okay. So, if you maintain same configuration, this two trained manpower will be training to another two people, so that they will share the work. For example, tomorrow if you change configuration, so that the trained manpower, it is a loss. It's a loss. Or if change configuration, they will be trained on different configuration. After some years, you want to design the initial configuration means again you don't get any trained experts. Again you have to start from scratch. You understood that? So the trained skilled manpower, I can say skilled technicians, skilled manpower, that is also one of the problem we may face if you are not maintaining the uniformity in the systems. You got my point? Okay, next. Other topics is okay, synergies in the production of the space and terrestrial solar cells. We discuss this one. PV cell. PV cell on the your home, PV cell on the space. So you have to maintain the similar components. Similar hardware. If you are changing, what is the affecting factors? What is the affecting factors? If you are changing the designs, what about your MTBF? It may change. Mean time between failures. MTBF will be changing. Right? No? If a MTBF is changed, what about your life cycle? Life cycle will get affected. Okay? If life cycle will get affected, you are not meeting your final goal. Correct? So you designed a system for 10 years, but it is not working for 10 years. Got the point? So that's why you have to maintain the synergy or uniformity while designing your systems for space and terrestrial applications. You understand my points? Very important value points. Next, substitution of terrestrial energy storage requirements. Okay. So what to do? What is the currently existing storage elements? We have battery to charge mobile urgently. Right now, that is one of the storage method, storage element. Right now, that is for low power requirement. If I have high power requirement, storage. So I have to go for batteries. Okay. Now, batteries. What is the type of batteries we are using? Is it a cell type? If it is a cell type, again, how many cells? What is is it lithium based? Is it lithium ion based? Is it lead acid batteries? Is it very different this one? You have to maintain all this one. For one system, I use lead acid batteries. For another system, I use lithium ion batteries. For another system, I use supercapacitor batteries. Okay? No, just assume. Now, for high power requirement, what is the preferred storage elements? How to maintain that batteries? How to maintain that batteries? How to design capacitance bank? What is the space availability to keep n number of batteries, and how efficiently you have to connect the battery loads in series and parallel combination to meet your output power requirement. So that for example, you have some 10 lithium-ion batteries. Tomorrow you want to replace 10 lithium-ion batteries with another type of batteries. Then you have to study what is the efficiency of this one compared to earlier one. If the efficiency of lesser than earlier means you have to increase numbers, you have to increase the quantity, you have to put more, right now, or you have to design effectively to have higher efficiency, lesser losses. Okay. Now, what is substitution for the future? Obviously, for example, existing storage is not sufficient. If I put a 124 GB memory card is coming nowadays in mobile, like 128 GB. Even that storage chip also not sufficient. Okay. Now, what is the alternative? What is substitution? Okay. So how fast I'm getting answers, sir? Good, nice. Okay. That's what. To produce that high capacity storage device, what is the technology required? For batteries, I'm asking. For batteries, what is the technology? Are we capable? What is the status, the current status of the batteries? How many batteries can be produced per month, per year? And what is our requirements? What is our needs? All these things need to be studied elaborately. What is our future requirements coming 2 decades, 3 decades with respect to space-based power generation? And whatever I am talking, that is with respect to space-based solar power generation. Okay. With respect to that, what is my capacity of generating power coming next 10 years, 20 years, 30 years? If this is my generating power, whether do I have sufficient storage systems to store that gigawatts of power? Okay. If it is not there, then what will be the substitution? If conventional batteries are not sufficient to cater for this requirement, do I have substitution for this? Yes, do I have. What is that? Supercapacitor. What is the design of supercapacitor? What is the benefit of supercapacitor? Whether are they reliable? Supercapacitors, are they reliable? Are they proven? Whether anybody has some experimental results? This is the supercapacitor I used for these many years. This is the power output supposed to give. This is the power output coming from the supercapacitor. This is the losses. This is the some experimental study is required. Then only we can accept that the supercapacitors can be one of the viable options as a substitutional storage elements. For higher power requirement, I believe. For a small one house, one town, one city, that's not a problem. But to store the gigawatts of power, we should work on substitutional storage mechanisms. Okay. One of the area where more research is appropriate, is demanded. Okay, right. Next, coming to the other topic here, space and terrestrial solar cell technology. Okay. So again, what is a PV cell and how you are designing your PV cell? Whether what is the things, the materials required for your dipole antenna, and what is the Schottky diode, for example? How many Schottky diodes are there? How to produce? What is the material required for Schottky diode? Whether all those things will be available next 30 years? Whether all these things will be available next 50 years? If any company is not unable to supply this, what will be your other option? What will be the other option? You have to identify the manufacturers also parallelly. If this manufacturer closing his company means, you have to get it from some other manufacturer at the same rate or little higher. Okay, so all these things, if you are not doing that, what is the problem? If you are not doing this, what is the problem? You don't get components. You don't get hardware, then how can you design your system? Your design will stop in between. There are 3 phases I told, 3 elements for the complete design of space-based solar systems. So phase 1, phase 2, phase 3. So phase 1 you have completed, phase 2 you have completed, phase 3 you are doing right now. There are no components available. What we will do? Already cost incurred, already we spent lots of crores of amount in manufacturing part A design, section, phase 1 design, phase 2 design. You understood my point? So you have to maintain the industries also. You have to maintain companies, manufacturers, insisting them to supply another next 10 years, 20 years, 30 years. That's what he was pointing out, supply chain management. That is very, very one of the core points. So if you miss that, it will be chaos. All your money spent will be wasted, or you have to wait. You have to wait until another alternate vendor need to be developed that equipment. You have to wait 1 year, 2 years, more than that. Okay. So always better to have two separate vendors for the same component. Why? Minimum 2 alternative sources is required. Why?
One is not one is not.
Okay. If one is taking monopoly, then we go for a second option. Correct? No? So you design one component, you are telling 1 crore for one number. Correct? No? Then why I have to come to you? I have other source, 50 lakhs, I will go for other source. Correct? No? Or I will do like this also. I have requirement of 100 numbers. 50 numbers I will go to first one. Another 50 numbers I will go to second one. Okay? So that both the manufacturers will be benefited. And both will be there in the line. Both will be there supporting under 10 to 30 years. What my point? So that's more important. So these things will be taken care of a separate team, maybe MBA or HR management or some futuristic aspects. One separate team to have all these aspects: maintainability, supply chain mechanism, cost overruns, the timelines. All these things will be separate. Like people will be there to take care of all these aspects. So, being technocrat, your role is to design. Your role is to develop. Your role is to implement your design, to produce the equipment, to produce the hardware systems, and to make them work with proper integration, hardware, software, mechanical integration, whatever, by considering all these things. So, since it is a multidisciplinary mission, multidisciplinary project, synergy among all the teams is also to be maintained. Okay. So you are asking electronically, you are designed system to at what angle theta with respect to the sun rays. If the mechanical engineer is not maintaining the theta degree, then what will happen? The design of electrical engineer will go in waste. Correct? No? So you have to maintain the synergy. Your whole system you are doing for 1 gigawatt. So the materials are used for polishing your giant mirrors is of low quality, means you don't get correct, no? Expected power output. You cannot ask sun to give the sun rays with high intensity tomorrow, because my polishing of giant mirrors is of less quality for this particular mirror. So today I am using this mirror to produce sun rays of high intensity. You cannot ask. So you have to maintain the synergy among your teams. Yeah. So space and terrestrial solar cell technology, which we discussed already, and solar power plant, and of course antenna. Solar power plant and antenna. Okay. Cover this. Now what we will do, we will continue with the presentation, and after this I would like to give some assignments, maybe PV cell design, like the hands-on training kind of thing. I will give some problem statements. We'll just design some cooking. We'll just produce some solutions. Will it be okay? I'll give you as a homework. Okay? That will be okay for you? Okay? Okay, not okay? Not okay. W, fine. Okay, coming to our explanation or presentation, yeah. Advantages of space solar power, like unlike oil, gas, ethanol, and coal plants, space solar power does not emit greenhouse gases. Is it right or wrong? Solar power station won't emit any greenhouse gases. Yes. Unlike coal and nuclear plants, space solar power does not compete for and depend upon increasingly scarce fresh water resources. Okay. See, for your nuclear plants and coal and all, you need a lot of water resource, pure water resource. Okay. Why you want WTO? What's that? Pure water. You want to use no, but how do you convert? How do you generate nuclear power? Okay. Anyway, let's not tell from here. Anyway, so that water, pure water equivalent is not there for space power stations. Okay. Unlike bioethanol or biodiesel, space solar power does not compete. Okay. For increasingly valuable farmland or depend on natural gas derived fertilizer, all this. So for your conventional this one and all, petrol this one and all, possibly you need to have you need to have valuable this one resources, storage. I mean, how many tons of coal is there, how many bioethanol is there, biodiesel is there. So that demand is not, it's a naturally free of cost available solar source. There is no other processes are not there. There is no other industries not required. For this and all, lot of intermediate processes are there to convert crude oil into usable form. But this one is space, there is no such. There is no such. There is no competition. That's what I mean. Natural gas, coal, petrol. There's a competition. No, one company will come and give you the coal-based this one energy. One company will come and give you geo with less cost, free of cost. Just actually one example. So like that. Food can continue to be a major export instead of a fuel provider. Okay. So this is the outcome. This is the outcome. Food can continue to be a major export instead of fuel provider. So now we are exporting fuel. For example, say some related wherever we are importing also. That's a different factor. We can be a food exporter. How? We can be a food exporter. How? How this is linked to space-based solar project?
We can send the energy.
I have my solar stove. Solar stove in my kitchen. I don't want any conventional stove, gas stove. So I am using solar stove in my kitchen. Tomorrow, car stove may also can have solar stoves. Day after tomorrow, they may also have some solar stoves. Food can be generated, food can be exported. Okay? Utilizing space-based solar panels. So the link is working, the link can be workable, yes, workable solution. That's the point. We can be India, we can be food export also. If you utilize the space-based energy properly. Okay. So there are variety of applications are there. You want to think, variety of applications. Okay. So food, you see, food is a daily, daily requirement. Food. That's one of the major ones. Considering population of people. Unlike nuclear power plants, space, like solar power plants, will not produce hazardous waste, which needs to be stored and guarded for hundreds of years. Very valid point. Okay, very valid point. So in the nuclear power stations and all, lot of nuclear waste will be there. In coal plants also, lot of waste will be there. Industrial waste will be there. All that industrial waste, it cannot be like degradable. It cannot be like unable to compose. It cannot be for years. Okay, so like the situation is not there in space-based power generation. Okay, there is no industrial waste or those things, hazardous things. Those things is not there in the space-based. Different aspects, looking the same thing in different aspects. Unlike terrestrial solar, that means coal, which is there on your rooftop, wind power plants, space solar power is available 24/7, okay, in the huge quantities. Yes, okay. So this wind power available whenever you have the wind, tidal power available whenever you have the tides, waves, tides. Similarly, but space power will be available 24/7. So this is the ideas. Already mentioned this point. Yes. So it works regardless of cloud cover, daylight or wind speed. Agreed? Space power generation, it works regardless of cloud, daylight, wind speed, rain, gauzy atmosphere, dusty atmosphere. Rest of all this space power generation is possible. So these are the constraints in terrestrial solar power generation. All these are constraints or checkpoints in terrestrial solar power generation. Whereas these are not applicable for the purely space-based one. If clouds are there, if rainy season is there, terrestrial solar power panels may not work. But whereas space-based solar panels will work 24/7 always. Unlike nuclear power plants, space that does not hold any easy targets for them. One important point. Last point. So, if you want to destroy my station at orbit, is it possible for Yes. I have a solar power plant in Palamaneru. Is it possible to destroy like that? Possible. Okay. Whereas the similar power plant is there in orbit. Who will do the launch of the engine? And then where they will search by going orbit. Then we keep on running only. Okay, so that's one of the aspects. People cannot destroy the solar stations at that. Valid point, no? Yeah. So in continuation, unlike coal, nuclear fuels, space power does not require environmentally problematic referendum. Same thing. Rain, dusty, gauzy atmosphere, same point. Space power will work true energy independence for the nations that develop it, eliminating a major source of natural competition for limited earth-based energy resources. Yeah. The solar power generation is independence. How much you want to generate, there is no limit for you. Any limit is there? You have the limit only up to 100 gigawatt you can generate. This only permission given by the sun for you. Like that, anything is there? You can. There is no limit. There is no limit. Unlimitedly, you can go for a power generation. Okay. But whereas this one conventional power generation, we have limits. Per day, this many times only should use coal. Per day, this many hours only your nuclear plant supposed to run. Per annum, this many days only nuclear power plant is supposed to run. Like that, there are some limitations. Is there any such limitations for space plant? No. Yeah, unlimited, free of cost, unlimited. Right. Valid no? Right? So we are ending with same statement what we concluded in the first slide. Yes. Okay. So space-based solar energy is viable solution. Yes. Even though here and there some difficulties are there, even though here and there some challenges are there, we will come across. We will overcome all those challenges. Okay. Okay. Now, space solar will provide space solar will not require dependence on unstable or hostile foreign oil providers to meet energy needs, enabling us to expand resources in other ways. Like to other countries. For example, you need some foreign assistance in generating power from other sources. For example, crude oil. I can import crude oil from other countries also, instead of taking from my own country. Okay, so that crude oil I can convert into usable form. Okay, similarly, terrestrial-based conventional energy platforms, we can take assistance from foreign nations. Okay, but at paid cost, not free of cost. But is there any such limits for solar power? No, no such limits. Okay, is any country can put some limitations on you? No, there's a point here. No country can put limitation. But today, one country is giving me crude oil. Tomorrow they may say no. Okay, like this situation will arise for solar power? No. You got my point? There is a point. Yeah, for example, like solar power can be exported, we already discussed, can be exported to virtually any place in the world, and the energy can be converted for local needs, local requirements, local loads, such as manufacture of methanol for use in places like rural India, where there are no electric power available, no power grids are there. Space power can also be used for desalination of seawater. What is this? Desalination of seawater. What is this actually? You are lucky enough at Palamaneru. Your water from the ground is very good, very sweet. Okay, the content of minerals also very good. Whatever beyond the limits. Okay, no salty water. But some areas are there, especially coastal areas, where if you put both, you will get full salt water. You cannot drink that full salt water, right? So what you have to do? You have to convert that salty water into drinkable water. So that is what your desalination plants are doing. Per day, 1 lakh liters, 1 lakh amount of liters of water will be generated from the seawater. Plants are there at Pondicherry, plants are there at Chennai, plants are there near Vizag, wherever coastal areas are there and all desalination plants are there, which can produce the clean water from the salt water. For operating these plants also, we can use the space-based solar power. So solar power can be used for taking the food, solar power can be used for drinking water, solar power can be used for industrial purpose also. You see where we are ending. Okay, we started at space. Okay, we are ending at drinking water. Okay, this is the significance. Last point, space solar power that can take advantage of our current and historic investment in aerospace expertise to expand employment opportunities in solving the difficult problems of energy security and climate change. That's what greenhouse effect, net zero emissions, carbon emissions, and energy security. So that any problems we are facing, energy security, well, that means next 10 generations can give assurance power will be available. Energy will be available. Can you give energy security? So, but with the utilization of space-based energy, 24/7 availability of energy, at least we will give the assurance. At least you can tell, energy is available next 50 years, next 10 years. At least you can tell that. Okay, now, so coming to disadvantages of this also we discussed. High development cost. Agreed?
Yes, sir.
Where and all high development cost is required? Installation. Okay. Good. Okay. Hardware. Okay. That is subsystems. Okay. Next. Okay. Transport. Yeah. Good. Good. Launch vehicle. Design expert. We don't have any design expertise, so some research also required for the design to get expertise. Yes, right.
Time taking.
Okay. It will take more time. Within 1 day you can't do. Within 1 year also you can't do. It will take more time. Any other? Yeah, storage. Yes, storage. That is also one of the. Maintenance is expensive and difficult. Maintenance, any problem comes means very difficult. Okay, next time only whenever you are sending hardware along with the hardware, the person can be sent. Okay, right? No. Otherwise, what is the cost for launching vehicle? It's a huge cost for launching vehicle. Okay, next. Cost of payloads to take the materials to space. Expensive. Yes. What is WPT?
Wireless power transfer.
Wireless power transfer. So, which may leads to natural and health hazards. Health hazards like
Skin, eyes,
blindness, skin irritations. Yes, all those aspects. The size of antennas used are large and very expensive. Very expensive. So, it will constitute acres, more than 20 acres. And costly also. Now, coming to challenges. What are the challenges? Now we have seen the advantages, we have seen the drawbacks, now we are going to see the challenges. What are the challenges? So the most important significant technical challenges is the development of low cost reusable space access. I mentioned once again, low cost reusable space access. Okay, understood that? முதல்ல அங்க போறோம் அங்க போறதுக்கு அப்புறம் தான் நம்ம இது பண்ண முடியும். Okay, go there initially, then only you can do something there. If you don't have access, how will you go? Okay, so for going there you need launch vehicles. Launch vehicles you need, you have to design. That is ISS. ISS you have to design. What is ISS? Dealing with the launch cost, demonstration of space to earth power beaming. Yeah, it's very important. Very important. Laser beam coming from space to earth. It should be doubly ensured safety. Say for example, you have to declare the zone as red zone. Wherever you are transferring laser beam from space to this rectangle, that the zone you have to declare as red zone. Why you have to declare as red zone?
because it is restricted area.
Okay, you cannot go there. Come on. By mistake also, helicopters cannot go, aeroplanes cannot go, drones cannot go. If they go, they become smashed. Correct, huh? So to take care of all those aspects, that zone we should create as a red zone. Okay. Next. Efficient and light space qualified solar arrays. You have to maintain the good design, efficient design, and efficient production. Space assembly. What is space assembly? Maintenance and servicing. Yeah, that's what we discussed. How instead of integrating your jet mirrors with theta degree angle, if you integrate with theta plus delta theta angle, that's all. I mean, you don't get the desired output, right? That means you have to carefully you have to integrate the systems. It's not easy. It's a tedious job and a tough task also. Is it easy task? A tough task. Tough task. And maintenance. Maintenance also controlling. Any problem comes there, you have to go there and rectify, or you have to call it back. Again, you have to take it to space. It will take more cost. It will take more time. Very difficult. Servicing. What is servicing basically? What is maintenance? What is servicing? Regular checking for errors is maintenance. Good. What is service? If any error comes, you have to solve that error. You have to keep that bug. That's called service. Any instrument point of view, any system point of view, like maintenance, there are three aspects. Regular maintenance, like a periodic maintenance we will do after every 3 months, every 6 months. Preventive maintenance. preventive maintenance. For example, I am getting some spikes, power spikes in house. What I will do? I will install the absorbers, like arresters will be sitting on the top of the buildings. Why? Remove money. Lightning arresters it will take all the power. It will get short to the ground. Your house will be safe. You are safe. That is called harm. Similarly, for any system also, expecting failures, you are taking care of yourself. That is called preventive maintenance. Okay. Periodic maintenance, every 6 months, every 3 months, every 1 year, doing my cycle is there. Every week, one Sunday, I will do maintenance. Any grease required, like that. Periodic maintenance. Preventive maintenance, periodic maintenance, and post-fault maintenance. Any fault comes also, after the fault occurs, we have to do the maintenance, post-fault maintenance. So these are the three aspects considering maintenance point. Okay, preventive, periodic, and post this one. Okay, so these things, assembly, maintenance, servicing, is a very tough job in space structures. For example, you say any giant mirrors are polishing, some issues there. Some polishing came out from the mirror. Again, you have to do that polishing, repolishing. That is tedious job. You have to use launch vehicle, you have to send exports, and you have to do like specified pipe for the giant mirrors. It's a tedious job, especially doing in orbit. Okay, so that's one of the challenges. That means assembly, maintenance, and service of space-based power plants is a big challenge. Yeah. Also, large cost of launching a satellite into space. Satellite, I mean here, space-based solar plant. Space debris is also a major hazard to large objects in space. That may interrupt you when you are transferring your hardware from Earth to space. That may interrupt you. So which cause again you have to stop the mission, or you have to call it back. You have to redo all the costs involved. The energy required for producing and putting solar panels into space versus amount of energy generated. Yeah. What is the amount we are putting for making the plant ready, and what is the power generated? If you compare, maybe the first one will be higher. You got my point? The power generated and the cost you invested, if you equate that to the power, that will be more than what you generated initially. So this may not be the reason after over the time. Over the time, your generated power will be increasing in terms of gigawatts. One of the solutions can be, we can utilize the concept of space elevators. Space solar power development cost will be very large, but its cost always needs to be compared to the cost of not developing space solar power. That means that, no, by telling this reason, by having this reason in mind, whether we don't want to start solar power generation? No, we have to start. Even though drawbacks are there, even though challenges are there, even though disadvantages are there, we have to go for this viable option. Since it is available 24/7, 365 days at free of cost from the natural source of the sun. Yeah. So people should work on some sort of wireless techniques, WBT, to transmit the trapped solar energy stored in satellite back to the Earth. Of course, the WBT only. So on WBT, apart from laser, apart from the microwave mediums, so we have to do some other research also. The whole working and processing of the system must be cost effective. That means at each phase of the design, initial phase, and then second phase, and then third phase. At each phase, we have to work out the cost effectiveness. I mean, in developing the hardware, in developing the software, in effective integration, in effective maintenance, in effective servicing. In all these aspects, we have to maintain the economical point of view, cost point of view. That also to be do some research and simulations, economical point of view. Okay, coming to the present status, there are many technological challenges to solve before the space-based this one can be implemented. However, in principle, researchers are getting close to the stage where it is feasible and they have just moved from the study. So, sometimes it happens, we almost designed a system, hardware fabricated, integrated, almost we are reaching the final point, but I don't have money. I don't want to invest more than this. Already some crores of money has been invested. Cost is equal. I don't want much more. I don't know whether I may be resulted in a loss or profit. Even certain factories are at that stage also. The present stage are. So those things to be pushed into positive side. Yeah. People have started preparation for world's first demonstration of 1 kilowatt class wireless WPT, and they are aiming for practical use in coming 2 decades. WPT, 1 kilowatt wireless power transmission in the WPT techniques. The solar energy available in space is literally billions of times greater than what we are using on terrestrial. Correct? No? It is a more, in terms of, there is no comparison at all. What we are generating energy on Earth, that is terrestrial solar power generation and space-based power generation, there is no comparison in terms of quantity. So this technology on a larger scale combined with the already demonstrated wireless power WPT and can supply nearly all the electrical needs of our planet. If WPT gets success, for example, if WPT gets success, so this can be implemented in every country to meet the needs of each and every industries, each and every individual agency. Space solar power can completely solve our energy problems and it can give the energy security for coming generations. So the sooner we start, the harder we work, the shorter, longer. Yeah. So another point, conclusions. So only thing we have to work out. We have to do more research and we have to work towards challenges. So this only will help us in coming days. Okay. Thank you so much for listening. Any questions? Yeah, I wrote my name on the display.